This is my Rube Goldberg machine. Step 1 will be me hitting these dominoes. Step 2 is the dominoes knocking down that golf ball down this cardboard ramp. Step 3 will the golf ball be hitting this rock that is connected to the tip-up line. Step 4, that knob will spin, releasing this flag, leading to step 5, which is knocking this cup, which is full of marbles, down this ramp onto the marble track. The marble track is step 6. The marbles come all the way down. They'll come out of there. And then step 7 is the marbles hit that baseball. The string triggers this pulley system, which lifts this cardboard gate up, releasing the bus. That is step 7. Step 8 is the bus hitting these books, leading to step 9, where the books launch the paper into the garbage can, which, as you can tell, is over 3 feet. That's 5 feet. Hopefully it works. For average speed, I chose the golf ball. I'm going to calculate the average speed going down the first ramp. The distance was 0.787 meters and the time was 0.93 seconds. If I take that distance divided by that time, I get 0.85 meters per second. For the 3 forms of acceleration, all 3 forms happen on the golf ball ramp. The first form is shown right there as the golf ball is coming down the ramp, increasing its speed. Change in direction is shown as it cuts the corner and the golf ball changes its direction and heads down this ramp. The decrease in speed happens right here as this ramp slopes up, causing the golf ball to slow down. For the forces of air resistance, gravity, and friction, I chose air resistance for the tip-up flag. The tip-up flag, right here, will be launched in the air, and as the flag is flying through the air, the flag itself will catch air resistance and slow down the flag before it hits that cup. Brady is shown as the marbles come and hit the baseball, and the baseball falls and triggers that cardboard ramp. Right here, as you can see, the marbles will hit that baseball, it'll fall off, and gravity pulls it down. 2 forms of friction are shown in my Rube Goldberg machine, both rolling and sliding. Rolling friction happens at the marble track. As the marbles come down through the track, they are rolling down each rail, thus the name rolling friction. Sliding friction happens right there on the gate. The baseball will pull up that cardboard ramp, and that ramp slides through these duct tape rails, thus the name sliding friction. For gravitational potential energy, I decided to choose the rock that triggers the tip-up. The calculation is mass times gravity times height. The mass of the rock was 0.485 kilograms. Gravity is 9.8 meters per second squared, and the height was 0.762 meters. I multiply all those together and I get 3.62 joules. Elastic potential energy is shown in the tip-up. In particular, it's the spring in the tip-up. The tip-up has a spring attached to the flag that is bending down, being held by the little knob that will be triggered by the rock. Once that rock falls, this will spin, and the elastic potential energy will then turn into kinetic energy, launching the flag forward. For kinetic energy, I chose the school bus. The school bus is hidden behind this cardboard ramp and will be released once the cardboard ramp is lifted. The calculation for kinetic energy is half the mass times velocity squared. the mass of the school bus was 0.222 kilograms and the velocity was 0.64 meters per second. Once I did the calculation, I got a total of 0.045 joules. For the 3 energy transformations in my Rube Goldberg, it starts with the golf ball. The golf ball is going to come down these ramps and it's going to hit this white rock that triggers a tip up. This is carrying potential energy. The golf ball will be carrying kinetic energy, and it'll transfer its kinetic energy to the rock, making the rock have kinetic energy dropping it to the floor. The second form of energy transformations in my Rube Goldberg is the tip up. The tip up holds elastic potential energy, and once the rock falls, the flag will be released, transferring the flag's kinetic energy into the potential energy of the red solo cup, making that tip and fall over. The last energy transformation will be shown by the school bus. The school bus is going to carry its kinetic energy through that gate, and it's going to transfer its energy into those books which are holding potential energy, and the kinetic energy will transfer through every one of the books to the catapult. Newton's first law states that every object will stay in motion, or every object will stay at rest unless acted upon by an outside force. That rock is not going anywhere unless something moves it. In this case, it's the golf ball. The golf ball is going to knock that thing off, thus Newton's first law. Newton's second law states that the force of an object is equal to its acceleration times its mass. I chose the school bus hitting the books to find the force of it. The mass of the school bus was 0.222 kilograms. The acceleration was 1.286 meters per second. And I multiplied the two and I got 0.285 newtons. Newton's third law states that for every action there's an equal and opposite reaction. This happens with the book dominoes. For every book that hits each other, it'll hit it with the same reaction and the same amount of force. The main errors in the machine itself were just position issues, like positioning the flag just right so it would hit the cup, positioning the baseball so it would fall over once the marbles hit it, and positioning the rock so it would fall off when the golf ball hit it, and the most important one was positioning the books so they would perfectly fall in that catapult, launching the paper into the garbage can.